So today let us see what is GIS and how this GIS is useful for surveying purposes of surveying purpose, or what are the various applications of these GIS in any form of engineering, not only civil engineering. This is being used in many other engineering also these days. Okay. So the basic definition of GIS is it's nothing but geographical information system. Okay. Geographic Information System. It is an organized collection of computer hardware, software, geographical data, and personnel designed to efficiently capture, store, update, manipulate, analyze, and display all forms of geographically referenced information. So basically, it's a combination of hardware, software, and data, geographical data, and person. Okay. So what can be the hardware? A system, computer hardware, a system, CPU, a scanner, etc. kind of thing. Software, there are many softwares like ArcGIS, ArcInfo, ArcView, MapInfo, AirDAS. Like this, there are many softwares existing in the market, and QGIS is one more software which is freely available or open source software. What is geographical data? So how the data is represented in GIS? What is geography?
Study of
What do you mean?
Earth.
Study of the Earth
Earth.
surface. Okay. So what is geographical data then?
Data regarding the Earth surface and previous past.
Data regarding the Earth surface, but with a
Previous and
precise
present.
location. With a precise location where normally if you ask anyone where is MBS Engineering College, everyone will say that you go from Balapur crossroads, take left, go for 5 kilometers, then on the left you'll be getting the MBS Engineering College. But what is the other way of telling where is MBS Engineering College? By its location,
Other
by
good.
its geographical location, that is by means of its latitude and longitude. Also, you can say that MVSR Engineering College is at 17 degrees 45 minutes east longitude, north latitude, and 78 degrees 45 minutes west east longitude. Like that, also we can say. So here, especially in GIS, geographical data is nothing but the location of that particular point or location of that particular area will be attached to that in the form of latitudes and longitudes. Okay. I hope you all know what is the latitude and what is longitude.
Yes.
చిన్నప్పుడు ఎప్పుడో చదివాం కదా.
Yes, sir.
What is the longitude and what is the latitude? Tell me now.
Longitudes are vertical lines.
Latitudes are horizontal lines, sir.
Horizontal lines.
Okay. What is the difference between two successive longitudes and what is the difference between two successive latitudes?
1 degree.
No. So latitudes differ by 4 degrees each and longitudes differ by 6 degrees each. These are the lines running parallel to the poles or the longitudes, and lines running parallel to the equator are called as the latitudes. Okay. So longitudes varies from east to west and latitudes varies from north to south. Okay. So a combination of all these hardware, software, geographical data, and person who is going to collect all these and do some processing or okay, are all called as a geographical information system. So that is, we are creating an information, we are collecting an information regarding the geography and trying to analyze that, okay, in order to fulfill our needs or in order to fulfill the needs of the client or user. Okay. But why GIS? Okay. Or what is a GIS? Geographic. It implies that the locations of the data items are known or can be calculated in terms of geographic coordinates, latitude, longitude. Okay. Where is my house? I want to determine where is my house with respect to latitude and longitude. I can determine that. Okay. Information implies that the data is in a GIS are organized to yield useful knowledge, often as colored maps and images, but also as statistical graphics, tables, and various on-screen responses to interactive queries. Okay, whatever information you want, you can attach that information to this geographic information, and you can do a lot of analysis. You can do, suppose I have a population data. Okay, I have the villages locations. So I'll be converting the villages. I will be having the village boundaries and I'll be having a point, a centroid point for each of the village. And I can link the census data to that boundary and point. Then based on that, I can do an analysis. How many people are living in a particular village or in a particular colony? Okay. And what is the how many literates are there, how many illiterates are there, how many general category people are there, how many women are there, how many children are there, how many SC/ST category, BC category kind of things are there, what is the annual income of those people. All those queries can be done with the help of this GIS software. Okay, and the result of these queries can be represented in the form of a statistical graphs or in the form of maps. I'll show you how the maps look at the end of this presentation. Okay, so
Repeat Rajat.
we are collecting all the information regarding a particular object or a particular feature on the earth surface, and we are going to use that information to do various analysis required by us. Okay, and system implies that the GIS is made up of from several interrelated and linked components with different functions. Thus, GIS have functional capabilities for data capture, input, manipulation, transformation, visualization, combinations, query, analysis, modeling, and output. So the information regarding the geography, that is latitude, longitude, is being collected. Other information is collected through the information system. These two are linked, and finally it becomes a geographical information system. And this system helps, in other words, you can also call it as a software, helps us to do various functions. We can capture the data, we can manipulate the data, we can transform the data, and we can visualize by changing different colors. We can visualize how the things are changing from one point to another point, and you can do the query, you can do the analysis, and finally produce an output which is going to give a good look for the administrators. Okay, if I give you information in the form of a table format, no one will listen, no one will see, and no one will understand also. I will give you 1,000 rows and 1,000 columns of data in an Excel format. What can anyone interpret from that? But I will represent the same 1,000 columns by 1,000 rows data in the form of a geographic features in the form of a map, and say that as the terrain is changing from here to here, or the rainfall is distributing like this, or the groundwater levels are declining like this. If I show that in the form of a map, then people will definitely understand it in a better manner. That is the advantage of GIS. Okay. And the other reasons why GIS is required is to invent and monitor resources. If you want to monitor the resources, how the things are changing over the earth surface over a specific period of time, we can use GIS. To test the sensitivity of our analysis assumptions, you can do analysis by other techniques, and you can compare that with the GIS also and confirm whether you are getting the same or not. To simulate potential impacts of management alternatives. Okay, what can be the potential impact of management alternatives? This comes especially for disaster mitigation and management. Okay, with the help of GIS, I can identify how many people are going to get affected. So based on that, I can give instructions to disaster management authorities that these many people need to be shifted from these affected areas before the disaster occurs or before the disaster strikes. And once those people are shifted to some particular location, I need to look after their health, food, etc. kind of things. All this planning can be done with the help of this GIS. Daily, how many people I need to shift, daily how much food grains are required to supply them, how many medicines are required, what type of specialist doctors are required. All those analysis can be done with the help of this GIS. Okay, and we can also do the mapping of geographical characteristics for analysis. What type of rocks are existing, what type of minerals are existing at what location, what is the quantity or what is the volume of that are existing. Okay, how to extract those things, all those detailed planning can also be done with the help of this GIS. Okay, we can also have some alternative processes similar to your GPS navigation. Whenever you see your Google Maps, okay, if you give the destination and origin, you'll be getting 2 to 3 maps, right? 2 to 3 routes you'll be getting, not a single route. So we can have many alternative processes also with the help of this GIS. And we can also manage a utilities assets. Okay, electric lines, telecom lines, etc., water lines, sewage lines, they all can be digitized and stored in a GIS system, and we can determine from which direction to which direction the flow is taking place. If at all an error has occurred, any individual user can also upload that query in the system, and it will be alerting the higher officials that there is some problem at this position, there is some problem at Hayatnagar, or there is some problem at Vanasthalipuram, so that the administrators or the government authorities will go to that place and will rectify that problem and again solve the query. Okay, like this, there are many uses which we can use, and these days GIS and remote sensing are being used in each and every application of civil engineering. If you want earthquake study, you can use. If you want landslide study also, you can use GIS and remote sensing. For water resources, you can use. For transportation, you can use. For environmental, you can use, okay, in each and geotechnical engineering also you can have applications. So in each and every part of the civil engineering, these GIS applications are being used. Okay, so basically it involves 4M. We call it as a 4M's principle. We are going to do the measuring, we are going to do the mapping, we are going to do the modeling, and we are going to do the monitoring. So 4M principle. Okay, we are going to measure the details in the field and convert them fields into the digital format through the means of mapping. Once the mapping is done, the data of the earth surface is converted into a digital format, or the analog data is converted into digital format. Then with the help of our requirements, we can do various models. We can develop various models. Suppose I want to develop a rainfall runoff model. If there is X amount of rainfall, what is going to the amount of runoff? I can do that analysis. If there is X amount of rainfall, what is going to be the future groundwater levels? That analysis I can do. If today the temperature is 30 degrees centigrade, what will be the temperature down the line in 10 years, whether it will be 35 degrees or 36 degrees? Those analysis, those modeling can be done with the help of GIS software. And you can also do the continuous monitoring, how the things are changing on the edge surface. Okay. And these are all the disciplines that are involved in GIS. Geography is required, mathematics is required, surveying is required, photogrammetry is required, analog photogrammetry and digital photogrammetry, remote sensing is required, and statistics is also required, automated cartography and cartography is required, and softwares like CAD, CSS, so computer softwares are also required. So all these disciplines are in one way or other way related with the GIS. This is the GIS architecture. So first we'll be inputting the data, or will the data capture subsystem. Okay, the data will be inputted into the software or into the system. Then the data will be stored, and the data can be retrieved also. We can access the data when and where required, and we can also manipulate the data. What is data manipulation? Suppose today I would enter the data. I have captured the drainage lines here. Okay, in the data input, I have captured the drainage lines. I have the drainage map in a hard copy. I will scan that and I will enter into the system, into GIS software. Then I'll try to digitize that. That is, convert the analog format into a digital format, and I'll store it. Suppose tomorrow there is one more drainage line that is added. A new house has come up, and the drainage line, the drainage outlet from that house is to be connected to the main pipeline. So that manipulation can be done here. Suppose one house is abandoned. So what happens? The drainage line should not come in meet to the main drainage line. So I can remove the drainage pipe connection from that house to the main line. So we can add or we can delete the data, or we can edit or we can modify the data using the data manipulation techniques available in the GIS. So first is we are inputting inputting into the system. Then we are storing and we are retrieving the data as per the requirement. Then we are trying to manipulate, that is, we are going to add or modify or edit or delete the connections, delete the objects or delete the features from the software. Then we are going to give the output in the form of a report, okay, or in the form of a map. So this is the transformation based view of the GIS. So from the real world, we are going to collect the data. That is going to be your raw data. Then that raw data is given as an input into the GIS system. That is going to become your data model. Okay. On the data, you are going to do the manipulations and analysis in the software. Then finally, you are going to produce the output data. Okay. So from real world to output, from analog data to digital output format, you are going to provide in the form of, with the help of a GIS. Okay. So these are the key components of GIS. You need to have a computer system with a good hardware and software capturing. Okay, hardware and software capabilities. This computer is used to capture, storage, process, analysis, and display the data. Then you also need a spatial data. Without data, there is no use of any GIS. Unless and until you don't have any data, you can't do anything, any analysis with the system, with the computer. So the geospatial data can be maps, aerial photographs, satellite images, statistic tables, topographic sheets, any data. Okay, whatever data, contour map data, any data, whatever you want, you can use that as the data. Okay, that data will be entered into the system, computer system. Then it will be analyzed. Then finally, it will be given to the users as per their requirements. If I want only how the rainfall trend is changing from one place to another place, I'll be given only the data of regarding that. If I want to study only how the patterns of groundwater levels are changing, only that data can be provided, that data output can be provided to the user. Okay, if I want to know how the population is varying, okay, in which village how much population is there, what are the categories of the populations, how many literates, illiterates are there, then I can do the analysis of that and give it to the concerned user. Okay, so these are the three components of GIS. So this is hardware components. You have a CPU, you have a system, you have a tape or a drive or a disk, printer, scanner, plotters. Okay. And these days for using the GIS software, you need to minimum have a 4 GB CPU, 4 GB RAM CPU. That is the minimum requirement because of a huge size of the GIS software. And these are the softwares. We have ArcInfo ArcGIS. This is one of the commercial software that is generally used in the market. Okay. ArcView was the earlier version of this ArcInfo ArcGIS. We have Span GIS, PAPIAMP GIS, Jira GIS, Intergraph, Nick Atlas. We have Map Info. Okay. And these days is even NV software is there, ERDA software is there. There are many software, QGIS software is there, GRASS GIS software is there. Many softwares that are freely available and many softwares that are commercially available. But the most used software is the ArcGIS. Okay. These days it is renamed as again ArcGIS Pro. Okay. I'll show you the interface of that ArcGIS software after this session. Okay. So how do we capture the data and how do we give the input to the GIS system? Okay, we can have paper maps and we need to digitize from the paper maps. So what we need to do is first is you need to scan the paper map and add the data to the GIS software. Then after that you need to digitize the features. Here you can see there are some light lines, blue lines which are visible to you. So what I'm doing, this is the base image or base photograph or base paper map which I've taken, I've scanned it and I've entered it into the GIS system. I can't create this image now. Okay. In order to do the analysis, what I need to do, I need to convert this raw format into a digital format. Okay. So for that, what I'm doing, I'm going to capture these lines. The center lines of all these roads will be captured and it will be shown as the linear features or the road features in the given area. Similarly, I can capture the trees, I can capture the water bodies. Okay. All those things, I can even capture the building plots, etc. kind of thing with the help of this digitization technique. So the main source is the paper maps. If you want, if you have a topographic survey of India topographic map, you need to scan that. Then you need to capture all these features which are available in that. These days, what is happening is using the satellite images also you can capture automatically the features that are existing on the surface or on the satellite image. Okay, but traditionally we need to go for the scanning of the paper maps, then do the digitization process. Digitization process is nothing but converting from the analog format into the digital format. Okay. You can even have this data in the form of traditional surveying techniques that also be given as input to the GIS system. You can have paper records can also be given. This photogrammetry, remote sensing and GPS, these three are the digital formats, already existing digital formats. The same can be given as the input. Okay, but these traditional techniques and paper records, they need to be scanned and then they should be given as an input into the GIS, then do the digitization, that is convert from analog to digital. Okay. And the data can be represented in two ways in GIS, that is spatial data and attribute data. Spatial data is nothing but which is having a location, a latitude and longitude, description by latitude and longitude. Attribute data is nothing but the data which is supporting the spatial features in the form of tables like age, name, okay, what is the category, what is the caste, etc. kind of thing. All those additional information can be stored in the form of a attribute data. So the spatial data is again of two types, raster data and vector data. In the raster model, the data will be represented in the form of a pixel, that is cells, 1 by 1 meter cell or 2 meters by 2 meter cell or 30 meter by 30 meter cell. Depending on the input which you are taking and depending on the output which you want to project, you can decide what is going to be the dimension of this cell. So the data will be represented in the form of a cells. In vector data, we'll be representing the data in the form of a vertices. The same shape, you can see the chair here, it is represented in the form of a blocks. Here the chair is represented in the form of a lines, which are actually the joined by which you got actually by joining the number of vertices in between. Here you will be having a vertex, here you will be having a vertex, here you will be having a vertex. So you'll be joining all those vertices or nodes, then you will be getting this shape in the vector model. The difference between these two is that amount of storage required for a vector model is less when compared to raster model. Here what I am doing, I am storing this whole pixel 30 meters by 30 meters. So if I convert this into digital format and I want to store it in the database, it takes more space. The same thing how I am representing here with a simple dot, a node of xy, a simple point I am noting here. I am load. Okay, so the space required for storing a simple node is very less when compared to space required to store one pixel. So raster models are always takes more storage space, whereas vector models takes very less space. Okay. And attribute data can be numeric or alphanumeric data that is assigned to a point or a line or aerial spatial features. Examples: compartment number, vegetation type, name of the forest block, type of road, VSS code, all these, your rule number, etc. kind of thing. Everything can be stored in a attribute formation in the form of a table, and this attribute information can be linked with this spatial data. That is the advantage of GIS. We can link non-spatial data and spatial data, or spatial data and attribute data. Attribute data is also called as non-spatial data. Non-attribute data is also called as non-spatial data or aspatial data. Is ASPATIL. Okay. So this is how you represent the features in the GIS. You can see there is a pond. There are some set of lines, black lines. Those are called as the roads or linear features. Pond is a polygon feature. Okay. Ticks are your control marks, the boundary marks. Okay. Node, you can see at every intersection of two features, there will be a formation of a node. These two roads are intersecting here, so it is a node. These two roads are intersecting here, it is a node. These two are intersecting here, it is a node. Okay. And these are called as generally arcs. We call the linear features as arcs, and this +4, +2, +3 are the label points. Okay. And this is the polygon, and this is the annotation. The name which is given here, pond, is nothing but the annotation. Similar to your dimensions, what you use in AutoCAD. The same way here also we have the same. But the only thing in GIS is the existing features on the Earth surface can be represented only in three formats in GIS software: either point format or line format or polygon format. Whatever feature that is existing on the Earth surface can be represented only in three formats. Okay, so all the trees, traffic accident post, lamp post, etc., can be presented only as a point on the geography in the GIS software. You can see here, this tree can be represented only as a point. Okay. And the line features, all the roads, streams, and railway lines can be represented in the form of a linear features. That is the line features. Lines are nothing but a series of geographic coordinates joined. So coordinates xy, 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 you will be having at some distances that if you join, you'll be getting a line feature. And all the areas, the water bodies, etc., kind of thing are represented in the form of a polygons. Water bodies, playgrounds, buildings, agricultural fields, forest area, etc., are generally represented in the form of polygons. Road features, railway features, canals, streams, drainage patterns, etc., are represented in the form of a linear features. Okay, and lamp post, trees, etc., are represented in the form of a point feature. But only these are the three types of features which we can represent in a geographical information system. Okay, in any other format you can't represent. You can represent only in these three formats. Okay. Now I'll show you some few examples of just opening the software. Give me 1 minute time. So this is the data of a Sarunagar watershed. Okay, you can see this blue color which you are able to see. These are the water tanks. So this is the Sarunagar water tank. This is Chandana Cheru, Mantrala Cheru, and this is
Your
Lelinagar
screen is
Cheru.
not
Your
visible,
screen
sir.
is not visible.
Avuna? Now is it
Hello.
visible?
Yes, sir.
Okay. So this is one area, the land use land cover map of Sarunagar, where this blue color you are able to see, right? These are the water bodies. Sarunagar tank, Chandana, this Chandana tank and Mantrala tank, and this is Lelinagar tank, and this is a small water pond available in the RCA, DRDO. Okay, and this is Bairamalguda pond. Okay. So similarly, this brown portion is nothing but the barren land, which is open land, open soil. This pink color is the vegetation. This is complete is RCA and DRDO portion. So the vegetation, this is vegetation, and this green color is the built up area, houses, buildings, roads, etc. kind of thing. Okay. So how, if I have a data like this, I can do simple analysis. What is going to be the area of these water bodies? What is going to be the area of these polygons? Okay, I'll simply show you once. Okay, for the, suppose I want to capture, I want to determine what is the area of this polygon of this water body. So what I can do is, is the screen visible?
Yes, sir.
Yes, sir.
Yeah.
So I can simply capture like this. I'm just drawing roughly, okay? I can simply draw like this. Then I can determine what is the area of that polygon automatically. See here in the table you are getting shape, length, shape, area, right? So you can do the calculations here, calculate geometry. I can get what is the length and what is the area. You can see here now the area is 2,94,061 square meters. This is in square meters. If you want in kilometers, square kilometers divided by 10 to the power of 6. So you'll be getting 1, 2, 3, 4, 5, 6. 0.29 square kilometers is the area of this polygon. Now compare yourself how to calculate the area of this polygon using conventional surveying techniques. How much time does it take to calculate what is the area of this water tank if you want to use your total station or normal conventional surveying techniques? That is the advantage of this software, but it takes a lot of time to bring the data into this format. Okay, so you need to have a satellite image, or you need to have a survey of India topo sheet or any paper map. Then you need to scan that, then do the digitization. Then only you will be getting these formats. After these formats are obtained, you can do the calculations easily. Automatically, the software will provide you what is the length, what is the area, what is the perimeter, etc. kind of thing will be given to you. Okay. Now suppose if I want to determine what is the length area of this barren land, I can capture this and I can determine automatically. And simply using one command in the software, I'm getting what is the length and what is the area of that. Okay, so that is the power of GIS. And you can see the maps can be shown within different colors. Okay, you can change the color schemes, whatever color you want, you can select. The look changes, so you can present it whatever format you want, so that it will be appeasing to the users. Okay, and it will be easily understandable by the users also. By seeing this map, you can say that, okay, this complete portion is built up area. This complete portion is vegetation. This complete portion green color is barren land. This red color is water bodies. Like that, if you explain to the government authorities or the clients or the users, then they will be understanding it in a better manner. How the features are distributed, whether there is less amount of vegetation or whether there is more amount of vegetation or whether there is sufficient amount of vegetation, whether there is more barren land. If suppose this barren land is there, here more barren land is there. So what can I do? What the administrators will think? Suppose they want to construct some double house buildings, double bedroom flats. If they want to construct, government want to construct. So if I give a map of like this, showing where is barren land, where is vegetation, where is agricultural land, etc. kind of thing, they can take a call, right? Okay, if I go for construction of double bedroom flats in this area, is it feasible or not? From how far it is from the city? What are the facilities I need to provide to them after construction of these flats? Those type of analysis can be done by seeing these maps. Okay. Suppose this is 2 acres. I got this information from the GIS that there is 2 acres of land available at this place. So how many flats I can construct? How many people I can accommodate in that? All those analysis can be done by the clients or by the government authorities if you provide the data in this format. But if you say that, if you give the data in the form of a table, okay, in Sarur Nagar there is only 2 acres of land available. Okay, at what location, what are the features or what are the features that are surrounding that location? If you don't give that information, if you give that information in the form of a table also, people can't understand that clearly. People will understand, no doubt, but the impression or the time taken for decision making will be very fast if you show that in the form of a map, whereas when compared to that, when you're showing it with the form of a attribute data, that is in the form of a word documents or in the form of a tables, etc. kind of thing. That is the difference between GIS and normal works. Okay, so you can capture any feature like this. So this process is called as digitization. Converting the raster data to vector data is called as the digitization. Okay, this is the most laborious process in this, but once this is done, then you can do a lot of queries. You can do a lot of queries in this. I'll show you here. See here. If I want to determine now how much amount of each step, BA1 is barren, BU1 is built up area, V1 is vegetation, W1 is the water bodies. If you want to determine, okay, what is the area of each of these features in this boundary, I can do that also using this software. Just give me a moment, it is taking time. So here 0 represents barren, 1 represents built up, V1 represents, 2 represents vegetation, 3 represents water body. So I'll show you how. I can calculate the areas of all this now easily. And I can show you the areas of all these within a fraction of minutes. It is processing, just give me a moment. See, now it is processed and I'm segregating all the 4 classes. So what I need to do is I need to simply add an area column. Okay, let it be float, say S. Here, each cell here is 30 meters by 30 meters. You are seeing these cells, right? These dimensions is 30 meters by 30 meters on the ground surface. You can see here also. See here, it is 0.03 kilometers by 0.03 kilometers. That is 30 meters by 30 meters. Okay. So to get the area, what I need to do, I need to multiply this number of count multiplied by 900 divided by 10 lakhs. I'm doing because I want the area in square kilometers. 1, 2, 3, 4, 5, 6. Here. So the one is barren land. The barren land is accounting for 17.94 square kilometers. Next is water body. Sorry, first one is built up area. Okay, it is accounting for 17.94 square kilometers. Second one is water body. It is accounting for 0.8 square kilometers. Vegetation is around 11.4 square kilometers, and barren land is 11.8 square kilometers. So if I give this map and this table associated with that map, then people will be able to easily understand how much portion of what features are existing in this boundary. Based on that, they can go for next planning. Where they can plan, they can either convert the agricultural land into a built-up area, or they can convert the built-up area, barren land, into a built-up area. But they cannot convert a built-up area into some other area, right? They can't demolish the houses and convert that area into agricultural land, or they can't demolish the area and convert that into a barren land. Okay? Development means converting the other features only into a built up areas, so that there will be provision of construction facilities will be there, jobs will be created, etc. kind of thing. Okay, so these kind of analysis can be done using the GIS. This is one application in urban planning. Okay, like that you can have several applications. I'll show you some more examples also, which I think I have already shown yesterday, right? Is the screen visible?
Yes, sir.
Yes, sir.
So the same example which I have given you, we can have a continuous monitoring. You can see from 3rd July, 18th July, 11th August, 13th September, 28th September, and 4th October. I can get the satellite remotions and satellite images into GIS, and I can find out how much area is going to get inundated. On third, how much area is got inundated, I can simply capture as I shown in the earlier session. I can capture the polygons here. This blue color is the area inundated by flood. So I can capture a polygon like this and so say that yes, this much area is inundated on 3rd July. On 18th July, how the scenario is, whether the area inundated is increasing or decreasing. On 11th August, how the scenario is. You can compare here itself. 3rd August to 11th August, the area inundated is becoming less. But again on 13th September, the area is increased. Again on 23rd September, the area is decreased. Again on 4th October, the area is decreased. So if I have the data in the GIS software, I can do the analysis daily, how the flood is receding, whether the flood is increasing or flood is decreasing. That analysis can be done by me within a span of minutes, and I can update the disaster management authorities to take appropriate measures to safeguard the people as well as the property. Okay. So like this, we can do several analysis. You can also provide the information along with a map in the statistical form also, how many villages got affected. I will simply draw a polygon like this, and I'll select using a query in the software. I'll be getting this output like this. What are the villages that got affected? Assume that here 100 villages are getting affected with the flood. Each village has the population data. We have a census data, right? How many people are residing in a village, that information will be given to us. How many male, female, how many old people, how many children are there, all those information will be available in the census data. So if 100 villages are going to get affected, assume that in each village 1000 people are there. Okay, 100 into 1000, 1 lakh people I need to evacuate from that villages and provide them shelter for a week or 10 days or etc., depending on the flood scenario in some area. So I can plan for making the people, 1 lakh people, to move from the villages to the safe shelters. How much transportation cost is required, how many buses are required or lorries are required. Okay, that analysis I can do. What are the food grains that are required, what are the medical facilities that are required, all those analysis can be done with the help of this, and those information can be given directly in the form of a tabular column to the concerned authorities. As you deploy 1000 police personnel to shift them, you provide 100 doctors to provide treatment to them, you provide 1000 paracetamol tablets, you provide 1000 diabetic tablets, because these are the patients that are available there. Okay, you provide 1000 liters of milk for the children or for other people, for older people. All those planning can be done with the help of these maps. That is the power of GIS. So this is one more example. What roads got affected? Okay, suppose we had recent floods in Hyderabad, in Saroo. So if I have that flood map, okay, this green color is the flood map which I captured from this satellite image. Here you are able to see, right? From this, the captured boundaries is green. If I overlay that on the city data, I can know which colonies are getting affected because of flood inundation, which roads are getting affected because of flood inundation. Okay, all those analysis can be done with the help of this software. Okay. Am I clear till here? Am I clear till here?
Yes, sir.
Okay. So this is self-explanatory. What are the advantages and disadvantages? Okay. I'll share this. I've already shared this PPT in your Google Classroom. Please go through that.
Okay, sir.
I'm noting down the attendance which is available here in the list. Okay. Thank you for the day. Bye.
Thank you, sir.
Thank you.
Thank you,
Sir,
sir.
thank you, sir.
Thank you, sir.
Yes, sir.
Thank you so